Nomenclature in chemistry, especially for organic compounds, having some rules. Nomenclature in chemistry, there should be some two types of name we know. One is IUPAC and other is tribal name. Now we discuss about tribal name. Example of tribal names. Tribal name means most of the cases we know some gases, some materials as their common name. That should be Mars gas, that should be vinegar. Okay. Some compounds have large systematic nomenclature. In such cases, a short name of compounds is given as systematic name, while partial name is also considered as trivial name. So some compounds having some large systematic nomenclature. Okay. But in such cases, the short name of the compound is given as systematic name for simplicity. Okay. While that is partial name is considered as trivial name. That is called as trivial name. Okay, what is trivial name? Is nothing but that is some compounds having large systematic name nomenclature, and their short of name is given as systematic name, and while this partial name is considered as trivial name. Okay, as per example Mars gas, as per example vinegar. Okay, so nomenclature, first one we have to consider some rules. Okay, first one, substitute nomenclature, most widely used method. Okay, substitute nomenclature is the most widely used method, and names derived by their substitution of an atom or group into a parent structure. Means the nature of atom that should be attached with the particular compound, or the parent structure that should be having the compound, is considered as substitute nomenclature. Okay. As for example, this common name propanol, that is beta adenosine blocking agent. Okay, that should be considered as substitute nomenclature. There should be this type of beta adenosine blocking agent propanolone that is having a configuration. Okay, this is the IUPAC name. Okay, there should be lots of substitution can be there. One is isopropyl amino group is present, other is one naphthyloxy group is present, and all means OH is present. So that's why we get the name 1 isopropyl amino, that should be prefix 1, and 3 1 naphthyloxy, that is prefix 2. Prefix means what? If we know English grammar, you know that is suffix and prefix. Prefix is which is written previous of the compound, previous of the name, and suffix is considered as the term that should be attached with the name after that. Okay, that should be considered as suffix. If suppose there should be a name and then ene is attached with it, that should be termed as suffix. But if there is some compound there previously we termed as some amino or hydroxy, that should be termed as prefix. Prefix means which must be previously written, and suffix means which must be written after that. Okay. So there should be two prefixes are there. One is isopropyl amino group. There should be isopropyl amino group. This is the isopropyl amino group. Okay. One naphthyloxy group. This is the naphthyloxy group. And propan 2-ol. Propan 2-ol. Okay. There should be, if we consider the compound, we can divide into 3 categories. One is one isopropyl amino group. This is okay. Other is 3,1 naphthyloxy, because 3 carbon, these 3 carbon attached with the 1 hydroxy group of naphthyl group. Okay. And propan 2-ol. Propan 2-ol, because in if we consider this propyl group, there should be 2 carbon Br hydroxyl group. Okay. If we consider that is, this is propan group, propyl group. Okay, there should be side chain, there should be side chain. That is 1, that should be 2, that should be 3. There should be OH is present. So that's why we termed as propan 2-ol. So that's why we get, that is, one group is representing as principal group and called as suffix. Another substrains are called as prefix, arranged in alphabetical order before the parent. So there should be one group is P dominant, and that should be defined the compound is this type of compound. Okay, when we consider nomenclature, we have many groups like aldehyde group, keto group, acid group, amino group, aromatic group, so on. But there should be one group will be P dominant, and that should be termed as suffix. Okay, and others that should be considered as prefix. This is the normal method of substitute nomenclature. Okay, and we have to arrange whole over the name by alphabetical order. Okay, before the parent. So what the main thing, substitute nomenclature is most widely used method, because when we go the nomenclature, we have to first consider substitute nomenclature, that is parent compound and having some group of functional groups. There must be one functional group is P dominant, and that should be considered as suffix, and other that should be considered as prefix of parent compound. And these prefixes must be arranged in alphabetical order. Okay. Okay. Next one, that is common name dopamine. Common name is dopamine, but we have to consider IUPAC nomenclature. Okay. For most of the cases for competitive exam, there should be, we may consider some common name, but when any question there IUPAC nomenclature asked, we have to consider IUPAC nomenclature derived from what rules. Okay, we have to consider. So first one, dopamine having this type of IUPAC nomenclature, that is 4,2-aminoethyl pyrocatechol. Catechol having the structure that is benzene wedge, and their nearby other wedge is present. Okay, that is 1,2-hydroxybenzene, we can say commonly, or that is 2-hydroxyphenol, we can say. Okay, that is called termed as catechol. So 4,2-aminoethyl, 2-aminoethyl, because this carbon is 2. If we consider side chain, that is from this position we consider 1, 2, 3, 4, 5 and 6, because we have to consider from one functional group. Numbering that should be considered as from P dominant functional group. Here if OH is P dominant functional group, we have to consider this 1 carbon, this 2 carbon, this 3 carbon, and this 4 carbon, 5 and 6 carbon. That should be written in this side. Okay. So there should be 1, 2, 3, 4, 5 and 6. That is must be it termed as 2-amino-ethyl pyrocatechol. Okay. There must be four position of the benzene attached to it, one position of amino-ethyl group. Okay. And amine is present in 2 position of carbon of amino-ethyl group. So that's why we termed as 4, because 4 at 4 position of benzene, the whole of the chain CH2 NH2 attached. So we have to term 4, then hyphen, then in bracket 2-amino-ethyl, because amino group is present in 2 carbon of amino-ethyl group, and then we termed as pyrocatechol. Okay, pyrocatechol is a suffix because catechol is P dominant in that case. Okay, it having the common name dopamine. Okay, next one, this is 3 hyphen bracket 2 hyphen methoxyphenoxy propan 1,2-diol. There should be suffix 1,2-diol. So there must be this 1,2-diol is P dominant in nature, so we have to consider as suffix. And the other are considered as prefix because they are not so important. Okay. There must be 3 position, this 3 carbon attached with the 2-methoxyphenoxy group, because there should be benzene, OCH3 and OCH2. That should be termed as 2-methoxyphenoxy group, because in 2 position, if we consider this is 1 and that should be 2, so that 2 position having OCH3, so that's why termed as O-methoxy, and there should be phenyl ring attached with OCH2, so we termed as 2-methoxyphenoxy. Okay, because in benzene ring, that is at 2 position carbon having bear OCH3, so we termed as 2-methoxy, and as benzene ring attached with OCH2 group, we termed as 2-methoxyphenoxy, bracket close. And then propan 1,2-diol, because propan having 1 carbon and 2 carbon bear 2 OH group, so due to this it considered as propan 1,2-diol. And diol considers all basically considered for hydroxy group, OH group is attached with it, and as there is 2 OHs group is present, so we termed as diol, propan 1,2-diol. Okay. Next one method, conjunctive nomenclature. Conjunctive nomenclature used extensively in USA, United States of America. Okay, useful which compounds having parent chain carrying characteristic group is attached to a ring structure. There should be a characteristic group that should be attached to a ring structure, and combination of 2 parent structure, 2 hydrogen that should be lost. A 2 hydrogen lost is the main characteristic of conjunctive nomenclature. Okay, how we derive, how we understand, like that. That is 1,4-chlorobenzyl. Okay, because there should be 4 position, 4 carbon Br chlorine group. Okay, and 4-chlorobenzyl. Okay, benzene having 4 position chlorine group. Then 5-methoxy. 5-methoxy, like this benzene having this position 5-methoxy. 2-methyl, this indole ring having 2 position methyl group. Okay, so we then consider indole 3-acetic acid. So there should be the main characteristic is indole. Okay, indole is the main characteristic group that should be attached. Indole is the main ring structure. Okay, there should be characteristic group is present, that is 3-acetic acid. This 3 position having acetic acid. So this should be termed as suffix. But we have to consider other all things. Okay, so that's why we termed as first one 1, because in 1 position indole and benzene ring that should be attached. Okay, into 1 position indole and benzene ring that should be attached. That's why we termed as 1. Next one 4-chlorobenzene. 4-chlorobenzene because 4 carbon of the benzene ring having chlorine group. Okay, that should be termed as prefix 1. 5-methoxy because 5-methoxy 2-methyl. 5-methoxy hyphen 2-methyl means in indole having in 5 position methoxy group and 2 position having methyl group. There should be having, must be 1 characteristic ring structure. So there should be ring structure is indole. Okay, and there must be the main characteristic group is this, that is 3-acetic acid. At that position 3-acetic acid is present. Okay, so we termed overall 1-4-chlorobenzyl bracket close -5-methoxy -2-methyl indole 3-acetic acid. Okay, substitute name we can say 1-4-chlorobenzyl -5-methoxy -2-methyl indole -3-acetic acid. Okay, then we consider additive nomenclature. No atoms are lost in that case. Here that should be 2 hydrogens are lost. Okay, indole 3-acetic acid, there should be in that case 2 hydrogen are lost. Okay, because indole If we consider indole 3 acetic acid, so basically there should be consider indole having one hydrogen attached to it and then plus acetic acid. But actually not like that. There should be two hydrogen are missing in that position. Okay, due to CH2COOH, one hydrogen missing, and due to this substitution other hydrogen missing. But that should be not considered in that case, because there should be considered indole. Okay, 3 acetic acid means CH3COOH. Okay, that's why. But when we consider substituting name, there should be some variation. So we get indole 3 while acetic acid. 3 while acetic acid. Okay. So in that case, two hydrogens are missing. Now additive nomenclature, no atoms that should be lost. No atoms may be used to denote addition process. Hydroprefixes are used to denote addition of hydrogen. Okay. Hydro means there should be addition of hydrogen can be take place to unsaturated polycyclic compound. So additive nomenclature described that is no atoms are lost. First one. This is the difference between the additive nomenclature and conjunctive nomenclature, and may be used to denote addition process. Addition means some atoms that should be added to the double bond, triple bond, so on. And hydroprefixes that should be used to denote addition of hydrogen to unsaturated polycyclic compound. Okay. Unsaturated means that is they are having maybe double bond, maybe triple bond, which can are capable to take hydrogen from outside. Okay. So next one, that is 6 example of additive nomenclature. There should be 6 chloro, 7 sulfonyl, 2 hydrogen, 1, 2, 4 thalidiazine, 11 dioxide. Okay. There should be 6 position having chlorine group. This ring structure 6 carbon bears chloro. 7 carbon bears NH2 SO2, that is sulfamoyl group, and there should be 2 hydrogen and 1, 2, 4 thiadiazine, 11 dioxide. Okay, there should be 2 hydrogen are added. Okay, in this structure, so that's why we termed as 2 hydrogen, 2H. Okay, I think in that position there should be 2 hydrogen that should be added. Common name chlorothiazide. Next example, there should be 3 methyl, because 3 position 3 methyl, 3 O toluyl, 4 3H quinazolinone. Okay, the ring structure having quinazolinone, and there should be 3 position having methyl group. If this is termed as 1, 2, 3, this is 3 position. Okay, there must be mistakes are there. Okay, 1, 2, 3. I think there is mistake is there. Okay, we have to check. There is not 3 methyl. If we consider 1, 2, so we consider 2 methyl. Okay, 3 O toluyl, that is right. There should be 2. Okay, there must be 2 methyl, that is 3 O means O toluyl. Toluyl means toluidine group is present, that is benzene having CH3 group. Okay, and 4 3H in 4 position, say 4 position, 4 3H, that is there should be 3 that is 3H, that is 3 hydrogens are attached. Okay, so quinazolinone. Okay, replacement nomenclature. Heteroatom present in integral part of chain or ring. There should be integral part of chain and ring having some heteroatom. Uses prefixes denoting heteroatom. There should be prefixes are used to denote the heteroatom, that is the nature of heteroatom that should be attached with the chain. Here heteroatom considered formally to have replaced carbon atom. There should be atom oxygen. Symbol is oxygen. Oxygen, for oxygen we use ora. Sulfur for we use thia, nitrogen we use aja, and phosphorus we use phosphor. So there should be chain or ring having heteroatoms. Due to this heteroatom nature of heteroatom, we can say many prefixes. For oxygen we can say ora, nitrogen we can say aja, sulfur we can say thia, and phosphorus we can say phosphor. Okay. Okay. Then we have to go next, subtractive nomenclature. In this system, compounds can be named as derivative of parent compound by subtraction of atoms or groups. We first consider there should be additive nomenclature. There should be addition process can be there. Next, we consider subtractive nomenclature. There should be subtraction of atoms or groups that should be there. Okay, there should be subtraction can be there. Replace group may be double bond ENE name, triple bond that should be YNE. Okay, double bond ENE, triple bond YNE. We have to consider that is 2 oxa, that is 2 position having oxa, 5 aja, 5 position having nitrogen, and hexane. That is termed as subtractive nomenclature. That is 2 position having oxygen, so we can say O2 oxa, 5 position having nitrogen, we can term as 5 aja, hexane, overall hexane. Okay, that is must be 2 thia, 5 aja, hexane. That is 2 position bear sulfur, so we can say 2 thia, 5 position having oxa, that is 5 position having nitrogen, we can say 5 aja, and then hexane, overall we can term as hexane. Similarly, that is 159 position having nitrogen. Okay, in 1 position nitrogen, in 5 position nitrogen, and in 9 position nitrogen. So we can term as 159 hyphen triaja anthracene, because the whole of the ring structure is nothing but is a anthracene unit. So we can term as anthracene, derivative of anthracene. There should be anthracene having 3 carbon atoms replaced by nitrogen in position of 159 position. So we can term as 159 hyphen triaza anthracene, and that should be termed as subtractive nomenclature. Then we consider radio function nomenclature. This nomenclature is binomial and the functional class name preceded by radical name. Okay, there should be radical name. Example, methyl alcohol CH3OH. There should be, suppose there should be some radical is there, so we have to consider what radical? Methyl radical, right? If we consider, if we imagine that is methyl alcohol and homolytically fission is there, so we consider the developed radical as methyl radical. By this analogy, we can term as the whole of the compound, that is methyl, the OH group attached with the methyl radical, that should be termed as methyl alcohol, or we can better say methanol also. Okay, so how we define radio function nomenclature is nothing but there should be dimethyl ether. If we consider that is both of bond attached with oxygen with carbon oxygen bond, if homolytically fissions is there, if we imagine there should be 2 methyl radical is developed, so we can consider dimethyl radical, and then we termed as the whole of the compound as dimethyl ether. Okay, similarly there should be diethyl ether. Okay, then we consider locants. Locants are nothing but only number, that is 1 2 3 4, or we can say letter ABCD. Locants are nothing but that should be only number, we can say 1 2 3 4, or alpha, that is ABCD, or we can say alpha beta gamma also. Okay, they show the position of functional group or the position of prefixes in parent compound. In the previous structure, you may say there should be the positions are dictated, that at 3 position, O tolyle, 4 3H quinazo linon is present, 6 position there should be chloro group is present. So positions are fixed. Actually, we have to consider when IUPAC nomenclature, first one, the numbering that should be written. Okay, and this number is termed as locants. If we consider the numbering, that is 1 2 3 4 5 6, this numbering is termed as locants. So They showed nothing but position of function group. They showed nothing but position of prefixes is parent compound. They are placed immediately before these groups to which they relate, except in the case for traditional contracted forms of compound. There should be immediately used. We consider those of groups, so we have to consider first their numbering, and then we arrange the whole over the IUPAC nomenclature. So by this way we consider locants. But if we consider the common name, that is vinegar, that is marsh gas, that is oil of vitriol, that is other common names also, so we can not taken the locants. Okay, but if we consider IUPAC nomenclature, first we derive first locants. Okay, any compounds have one or more than one locants are generally the position of prefixes are showed before the parent nucleus, while position of suffixes are showed after the parent nucleus. There should be any compounds having one or more than one locants. That is not one, sometimes more than one locants are present. Okay, so generally the position of prefixes are showed before the parent nucleus. Prefixes, because prefixes are written in previously of the parent compound, so its locants are also considered in previously of the parent compound. Okay, but suffixes that should be added with the parent compound, so we have to consider locants of suffixes also considered as after writing the whole over the parent compound. Then we have to consider locants of suffix and suffixes. Okay, it is not necessarily all compounds shown have locants. It is not considered that is locants will be there. If we consider toluene there should be one CH3 group is there, so we may not consider that is this is there should be not needed to numbering the position of the methyl group. Okay, there must be one methyl group, so we have not considered so much. If there must be one chain is there, hexane chain, that is 6 carbons are present, sometimes we may omit the whole over the numbering. We may consider only that is this is a normal hexane. Okay, this is a normal hexane. Sometimes we may not consider the locants or position alpha, beta, gamma, or 1, 2, 3, or ABCD, so on. Okay, so not necessarily all compounds having locants. Number of locants depends on the attachment of radicals and function group. That is radical, like for example methyl ethyl ether, there should be methyl group, there should be ethyl group, so we have to consider that is radicals. Radicals means not radicals. If we imagine that is these bonds are homolytically efficient, so there must be 2 radicals are produced. So by this analogy we can term there should be radical, imaginary radical can be there, and there should be functional group can be attached to the parent groups. By this 2 analogy we can derive locants, and or we can say numbering. Okay, general nomenclature that should be locants. First one we have to consider locants, then hyphen prefixes, then hyphen parent, then hyphen locants, again suffixes. Okay, this is important rule. If we consider IUPAC nomenclature, that is first one we have to consider locants, that is then consider hyphen prefixes, then hyphen parent, then hyphen locants again, then suffixes. Locants that should be, suppose there should be 3 hydroxy 2 methyl pen to 1 in 4 wine. There should be 3 is locant of hydroxy group is present. Hydroxy is the prefix of the whole over the chain. Okay, 2 is the locant of methyl group. There should be 2 position having methyl group. 2 position is the locant of methyl. And then pent is the parent compound, because there should be 5 carbon chains are there, so pent is the parent compound. Then we termed as suffix, that is 1-ene. The 1 position having double bond, and 4-yne wine, that is 4 position having triple bond. Okay, there must be 3 is a locant of hydroxy. Hydroxy is the prefix of parent compound. 2-methyl, 2 is the locant of methyl group. Methyl is the parent compound. Methyl is the prefix of parent compound. Parent compound is what? Parent compound is pent, because there should be 5 carbons are there. Then hyphen 1-ene. Ene means 1 double bond is present at 1 position, and that should be a suffix, and 1 is the locant of ene. And then we consider 4 YNE. 4 is the locant of YNE, and YNE is nothing but that should be a suffix. That's it. Okay. Then this will be discussing later. Okay. Up to this. This is the general nomenclature. So what is the summary? That is nomenclature in chemistry is nothing but that should be derived in so many methods. Maybe compounds having common name. That in most of the cases we have to consider that is carbohydrate, amino acid as their common name. That is alanine, glycine. Okay. We have to not derive the whole over the functional group or so on. But some having tribal name and some having IUPAC name. Most of the cases the organic compounds are derived by their IUPAC name if we start from concept. Okay. Example of tribal names, that is Mertz gas vinegar. Some compounds have large systematic nomenclature, but in such cases short name of the compound is given as systematic name, and this partial name is also considered as trivial name. Okay. There should be lots of method. First one, substituent nomenclature. This is widely used, and name that should derive by substitution of atom or group that in the parent structure. That is, one group is P dominant. That should be termed as suffix. Suffix means which must be added after the parent compound. Okay. And others are termed as prefix, which are previously written before the parent compound. This is the example, that is 1 isopropylamine, prefix 1. Then 3, that is 1 naphthyloxy, that is prefix 2. And propan is the main chain, that is the parent compound. Then 2, all means hydroxy group, and that should be termed as suffix because all is P dominant in nature. Okay. Next method, conjunctive nomenclature, that should be extensively used in USA and useful. There should be parent compound and there should be ring structure which having characteristic group. Okay. And there should be 2 hydrogen are lost. Combination of 2 parent structure, 2 hydrogen are lost. Because there should be combination of 2 structure. These 2 structure, that is, one is indole, other is acetic acid. When they attach, there should be 2 hydrogens are lost. Okay. Additive nomenclature, there should be no atoms are lost, and maybe there should be addition process, hydrogens are attached. So we can, due to attachment of hydrogen, we can term as hydro prefixes or H prefixes. That is 6-chloro-7-sulfonyl 2H124 thiadiazine 11 dioxide. Okay, and so there is not 3-methyl, there should be 2-methyl 3-O-tolulyl 4,3H, because 4 position or adjacent of 4 position there should be 3 hydrogen are attached. Quinazolinone. Okay. Replacement of nomenclature, there should be heteroatom may be present, and due to heteroatom presence, we can term term some prefixes. As due to their presence, we can term as some prefixes. That is, for oxygen we can use ora, for sulfur we can say thia, for nitrogen we can say aja, and for phosphorus we can term as phosphor. Okay. Next one, subtractive nomenclature. There should be in the system compounds can be named as derivative of parent component. Okay. There should be by subtraction of atoms or groups are there. If double bond is there, so we can term as ENE. If triple bond is there, we can term as YNE. Okay. There should be, that is 2 oxa, 5 aja hexane. That is 2 position oxygen bear, 5 position aja is bear. Okay. Radio function nomenclature. This is a binomial. And functional class name preceded by a radical name. Radical name means if we imaginary observe, that is, there should be homolytical fission is there, and which type of radicals are produced. By this analogy, we can term as the compound. That is dimethyl ether. So there must be, if homolytical fission is there, 2 methyl radical are produced. So we can term as dimethyl radical, and oxygen is attached to both of them. So by this analogy, we can say dimethyl ether, and that is the radio functional nomenclature. Last one, locans. Locan is nothing but that is a numbering. Maybe we can use 1, 2, 3, 4, we can use alpha, beta, gamma, we can use ABCD. Okay, they show the position of exact functional group, number of carbon atoms, and position of prefixes, so on. Okay, they also written in IUPAC nomenclature for denoting the exact position of functional group, exact position of double bond, and so on. They are placed immediately before the groups that should be attached, maybe suffixes, maybe prefixes, but we have to consider locants before of this. Any compounds have one or more than locants, there should be generally prefixes are showed before the parent nucleus and positions of suffixes are showed after the parent nucleus, right? And all of the compounds not necessarily show the locants. Remind it. And number of locants depends on the attachment of radicals and functional group that should be attached. There must be general nomenclature having locant first of prefixes and then parent, then locant of locants, and then suffixes. Okay, so locants, hyphen prefixes, hyphen parent, hyphen locants, then hyphen suffixes. So we can term by this way 3-hydroxy, because whole of the parent compounds are pent, that is must be 5 carbons are attached, and in 5 carbon atoms having 3 position OH are attached, so we can term as 3-hydroxy. 2 position having methyl group, so 2-methyl, and then term as parent compound pent, and then 1 suffixes, that is 1 position having in and 4 position having YNE. So we can derive all over the IUPAC nomenclature. Okay. Okay.